recording this, I'll put up the new module, module 2, project 2 on Canvas after class, and embed this video on the first page. All right. Now, between now and Monday, I'll also have a more detailed outline of what we're going to be doing. But it shouldn't come as a surprise to you. We're going to go from here. This is where we all left off on Monday. Everybody who was here on Monday, I made sure you were at least here, right? A lot of you were already there. You guys just got to take Monday off. But I spent some time in here with a number of you one-on-one on Monday to make sure everybody's here and ready to bring this into Revit, right? So we're going to go today from this to, where'd it go? There it is. I'm so used to the Mac interface that when I go in Windows, I'm like a fish out of water, to this, right? You'll see some parallels here. One is we're going to make a 9-square grid again, right? 3x2x3 grid, but an architectural one, not just a series of lines, but one in which we start to build components into the model and set up associations between them. Okay. You'll see that I also have a column grid. I have levels set up. So we'll talk about this interface today. Again, if you've already done a lot of things in Revit, you'll probably be kind of bored, but you can start to work ahead. This is where I'd like everybody to work on over the weekend and be out on Monday. Just very, very simple. We'll start with the basics. So, what are the basics? Let's go back to Rhino really quickly. Let's talk about that. So, let me just open up this sub-D test 01, right? This is where I left off the other day. And you'll see that I have some layers here. I probably have some sub-Ds. I probably have some pipes, right? I just want the stuff I want to bring into Revit. Okay? So I don't necessarily want the sub-D geometry anymore. I just want the pipes. I just want the diagram. Like, that's what I'm going to bring into Revit. And so, what I'm going to do is just save a version out of this, right? So, what I recommend doing is just going to File, Save As, right? Which is what I did here, sub-D test to Rhino. And then I get rid of everything that I don't want to bring into Revit, okay? And I still have that old file, and if I need to go back to that sub-D, maybe quad-remesh it, change its settings, republish rebake another diagrid, I can. But this is the file I'm actually going to import into Revit. Getting rid of everything that I don't need. All I really want are all these struts and nodes. I'll leave the grid lines, even though I don't think they'll actually import in, at least by default, even. And I then can close out Rhino. I just need to make sure I know what this file name is and where it's at, because when I open up Revit, I start a new project, I'm going to import this Rhino file into Revit.
What view are you?
Sorry?
What view are you in Rhino?
I'm just in Rhino, and I'm just making sure that I just have the diagrid. All right, so let's just pretend we're starting from scratch here. File, new, and project, okay? Yours will probably just have this. Some of yours might say multidiscipline, or some might say just architecture, but what we want is imperial units, right? We want feet and inches as opposed to metric. Make sure that's set to project, not project template, and hit OK. Let's go ahead and start a new file. How many of you Revit's kind of new? Okay, half-ish. How many of you Revit's pretty old news? How many of you have done some Revit, but it's been a while? Okay, all right, so this will be good review. All right, here we go, starting up Revit with a new project. Oh man, it's like when you get into you go to the dealership, get a new car, and it's like, is that smell? Right? No? Oh, come on, right? The new car smell, but we have the new Revit smell here. So, what we're seeing here by default, right, is a set of tabs on the top with tools. We have a bunch of settings boxes on the left, and we also have something called a project browser, which shows us a bunch of things that we probably recognize, like floor plans, ceiling plans, elevation sections, 3D views. Okay. There's probably some extra stuff on here I don't necessarily need electrical floor plans and reflected ceiling plans for, we don't typically do that in school. That's something that you do when you're, when you start to move on from 60% DD set in the office, right? So anyway, and over here, you can see the actual project, right? So what it's telling us is that right now we're looking at level 1, so floor plan 1, right? You can see it over here. I can go back and forth and find all the different drawing types that I have over here, all the different views of my project, right? So I can, again, go to level 2 floor plan. You can see it's blank right now. There's nothing there, right? I can go to the section. Oh, look at this. There's elevations, east, north, south, and west. Not a big surprise, right? Again, all of these are blank at the moment. There's also 3D views. I think by default, there's one called cover sheet view. I find that to be the least convincing 3D view ever. So let's point out some of the tools at the top and let's get started, shall we? You see the tabs, file, architecture, structure, and then blah, 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 blah. Moving across. Most of what we're going to do in this class is in the architecture tab. You'll see there's a few exceptions to that, right? We'll go to the view tab and make some new views, like some 3D views. Make perspectives that way, move the camera around. We can make some axon views, right? We'll probably use the insert button to import some CAD files from Rhino into Revit. And when it comes to making some beams, we'll actually use the structure tab. But for the most part, we'll use that architecture tab. And you can see, right, as I start to move back and forth between the tabs, the tools along the icons and the tools along the top change, right? So when I go to structure, I see beams, walls, columns, floors, trusses, braces, beam systems, as an example. When I go to architecture, I see things like walls, doors, windows, columns, roof, ceilings, floors, etc., right? Over here, really important, we see something called grid and level. Ooh, I can't wait. So let's not delay any further. Let's bring in our Rhino model into Revit. All right? What's that?
I don't have any of those tabs.
Show you the architecture.
I like structure.
No. Maybe we can take a look at after class. But, I mean, my guess is we can turn certain things on and off. All right, so let's see, we are in section, all right, let's make a new 3D view. You can see that every single drawing type or view that I open up in here, it makes a tab up there and I can start to toggle back and forth really easily between them. This looks old. Why is this here? How many projects do I have open? Oh, Jesus. All right. Let me just close this and make sure I'm in the new file that I just made. Okay, great. So let's go to insert. Okay. There's a couple of ways we can do this. It used to be that we would probably make some sort of generic architectural components and then insert the CAD file inside. I see no benefits in doing that these days. What we can do is we can either import a CAD file, right, something from AutoCAD or SketchUp or Rhino or something like that. Or we can link it. What's the difference? Yeah, so linking will just say, well, I've linked up to this Rhino file. I'm always just whenever I open up this file in Revit, I'm just going to refer back to the Rhino file, however it is, and import it in temporarily, right? So if I go back into Rhino and change the file around, when I open up the Revit file, the link file will have been updated, right? And I'll see the updates. If I import it in, then I'm just importing the geometry from Rhino, making it into Revit. And I'm just going to go ahead and do that first, right? I'm just going to say import CAD. But, for instance, if you have too much geometry or something, or it's really bogging down your machine, you can always link it and then unlink it and then relink it as you need, right? To sort of refer to that Rhino geometry. So I'm just say import CAD. I'm in the insert tab. And you can see when I pull down the file types, I can import any of these types of drawings, right? Or sorry, any of these types of files. So you can choose DXS from AutoCAD, SAT files, SCSI SAT files, PGN, that's for microstation, Bentley. OBJ files, those are mesh files. Right, native Rhino files, native SketchUp files, and STLs, stereolithography format, right, for 3D printing. You guys know all your file types, right? Some of them, probably. Yeah. All right. So we all know 3DM, that's Rhino. And look at that. I can go now to where I saved my new Rhino file. I called it subd test to Revit, right? Sort of labeling it as this is the thing you bring into Revit. And let's just go ahead and import that in. Take this long before. You know, always when I'm doing this in front of people and recording simultaneously, that's when I get this thing to give you that. Let's see. This is not responding. No idea why. I assure you this does work. So maybe we'll give it a minute. It totally didn't take this long before. I spent the last 15 minutes before class reteaching myself Revit. Just went through the whole process really quickly. Like, oh, this is so those of you who are new to it, good. This is fine. You have the weekend. Some of you, what you're going to do is do some things that you're going to develop some muscle memory with, rather than moving things around and starting to place things. What's going on here? What? Jesus. Okay. All right, let me just reopen Revit, I guess. Take two. First you don't succeed, try. I like to say that in the recording, I'll just clip that first part out so I don't look like a dumbass. But I don't have time for that shit, so I'll just look like an idiot. It's all right. And herein lies my problem. I spend half my day waiting on the computer to do stuff. All right, there we are. I'll just start a new file really quickly. I don't understand what was taking so long before, but that's okay. We'll make do. New, Imperial, mine's multidiscipline. You see I have a number of things up here to use. Architecture tab's what we're going to be using most of. Just got to set up a new project really quickly. All right, it's almost there. All right, no reason to repeat myself. Let's go to Insert, and let's import CAD file. And let's find that Rhino file we made. And let's go to desktop. There it is. Subd to Revit. All right. Like I said, I literally did all this really quickly before class. Dang MacBook Pro. All right, let's see. If I get tired of waiting again, I can always just open up the one that I actually imported on in already. It's like a cooking show, right? Put something in the oven, but I'm also taking something out that's been in there for 40 minutes. Ah, there we go. It's there. All right, so a couple of things, right? First of all, let's look at this thing in 3D. So I'm just going to go to the View tab. You can see that under 3D View, if I click that caret, I have something called Default 3D View that gives me like an axon or isometric drawing. Then I have a camera, which I can then place and get a perspective view. I'm just going to use the default 3D view, and let's just take a look at what this thing looks like an axon. Just zoom in. There it is. Ta-da! Yeah, it looks pretty nice, doesn't it? Not too shabby. Just going to click on that axon box there, maybe. There we go. And change my vantage point here a bit. Yeah, there it is. All right. Now, what do I need to do? I need to reestablish the grid, right? We talked about that. With Revit, it's really important. I mean, one of the first things you usually do, get the site in here, and then establish the grid. We are using no site, but we'll worry about the site first. But what we need to do now is reestablish that 15-foot, 15-foot, 15-foot grid. Right? So we can do that several ways. First, what we can do is we can start to give center lines for this grid. Right? Then we can start to place components like columns and beams along those center lines. And what's nice about those is when you draw the center lines first, you draw the levels, then when you start to draw the columns and beams, they're connected to the column grid. So as you start to move the column grid, all the columns and beams start to update, right? So we'll do this methodically. And what I'm going to do is just go to level 1, right? That's my architectural floor plan. You can see I'm just cutting 4 feet above the floor, right? There it is, right? So that's my diagrid just cut 4 feet above the ground. And you can see it beefs up a little bit just where it's cut through and line weight wise, and yeah, there we are. All right, so we know in my case that was the center of this 3 by 3 sort of grid on the ground. Right? So are you guys ready to draw a grid? Let's draw some grids. All right, so in plan view, I go to architecture tab again. Most of the things we're going to do are in the architecture tab. I go over here and you can see where I have this label called data, right? Really important. We can establish column grids and plan, and then in section elevation, the Z direction, we can establish levels. And that lets us create a 3-dimensional matrix or grid to work with. All right. So you can see I have grid available. I'll click on it. Just watch, right? You can always rewatch this if you need to. I'm just going to go ahead and draw a column line. I'm going to make it bigger here. Let me just let me start up here a little further. Right? Click and a click. Right? I'm not really concerned about where it is, except maybe I hope it's close to 15 feet away from this edge. What I'm going to do is make a column grid, column grid, column grid. Or column line, sorry. All right. So, see what happens when I move my cursor? Let's see. Maybe. Here we go. Right? It sort of IntelliSense says, hey, you know, you want to draw another column line, right? And now it also gives me a readout in real time of how far away I am from the last one. Right? So let's say I want to make this one 15 feet. 15 feet and 0 inches. It pains me to no end how Revit doesn't do a mouse and trackpad like every other freaking program in the universe. Stupid Autodesk and their market share. They just don't want to do anything easy. All right, so a couple of things here, right? You can see I want to actually, I'm just going to eyeball it, but I'm going to make it a little closer, right? You can see now this is 18 feet away, so I'm going to go ahead and click and move this one. And just, you can see how it's going to start moving things in increments. If I zoom in further, it starts to get more granular in the things I can do things, right? And I'm just going to sort of, again, ensure that these are 15 feet, 15 feet. Okay. And now I'll just go ahead and make another one. Yay. Grid, right? We're in Architecture tab, Grid. And I'm just going to come over here and 15 feet. I'll go ahead and make the start point. All right. And we'll do it one more time. 15 feet, 15.6, 15.0. There we are. Okay. Now, there's a couple of things, right? You might start to try to click and drag and move these around. Sometimes it works and sometimes it doesn't. Watch what happens when I click this. You see this lock? I can unlock or relock things, right? What that means sometimes is that you can either lock the position or you can lock its relationship in with the first grid line you drew, right? All right. And it's the same thing here. There's ways to begin to constrain these things so that, let's say I always knew I wanted a 15-foot increment, but I think that the edge might change, right? I can make all of these things move along with this one. Or I could say unlock those and then start to move them independently from each other, right? So there's ways to build some of these associations in. And that's what's really nice about this. Again, it's parametric, just like Grasshopper, in the way you can begin to build relationships between things, right? In fact, when we do that, we'll start to build columns and beams, right? They'll be dependent on the column lines that we snap to, right? So if we move the column lines, then the columns and beams will adjust accordingly. All right, so once again, I'm still in grids. Let's go ahead and start drawing some horizontals. Man, the only thing I like more than vertical grid lines, horizontal grid lines. Oh yeah. Okay. I love me some grid lines. There's one. And I'll come down 15 feet further. Maybe I'll try to figure out roughly where I want to place this one. Then I'll move the other one 15 feet away from it. Here, 15 feet. You can see, again, the scale in the units should match up. This circle should fit in that 15 by 15 just fine. And look at this. Isn't that annoying? You get further away and you get closer to this line, and then it only tracks from that line. So what I'm going to do is just go back up to this arrow, just move this stupid center line down and away. We don't really care. For our purposes, we don't really necessarily need to worry about that. Now go back to Architecture tab and the grid, and we'll go down 15 feet and we'll establish a grid. So anyway, we're almost there, right? I hate that this is so boring, right? But what we're doing again is just drawing that grid. When you're in an office, they'll have their own standards for how these things start to match up, or depending on the constraints of the project, right? But this is usually where you start, right? Establishing that grid ordering system. All right, so we have this in plan. You can see when we go to first floor, we go to second floor, we still see the grid, right? Okay, now let's talk about those floors and let's make that grid in Z, right? So far I have level 1 floor plan, level 2 floor plan. I have an axon view, right? I can always go to elevations and sections. Why not? We'll just go to like the East architectural elevation, right? Now we can see it from the side. And with our architecture tab, if we go to the data, you can see that not only do we have the grids, but now we can start to make levels, right? You can see right now level 1 is set to 0, right? The sort of finished ground thing. Level 2 is set to 12 feet above that. We're going to go 15 feet above that. So let's adjust that first. I'll click. I'll zoom in a bit here. And I'm just going to drag this thing, and so it's 15 feet, right? There we are. All right. And let's see, I want to make another level, so I'll go ahead and do that. And I'll go 15 feet. There we go, 14.6, 15.0. There we are. 15 feet above that one. And then another 15 feet for level 4, the roof. All right. Yeah, you can see the elevation each time. So Revit's going to start labeling these things just like if you're building construction documents, right? 0, 15, 30, 45, right? That down to the ground and everything above it, its elevation. Okay. Let's go to the 3D view. Yeah, and you can see, although the spacing's, well, no, this says 15, 30, I don't know what's going on there. Oh, I see. It's because this thing goes a little further. Anyway, you can see that we have these levels, right? As well. All right. So each time we add a level, we get another floor plan, right? So we have the floor plan at level 3. You can see each time it's cutting it wherever that level 3 is, 4 feet above it, using that cut plane, like a clipping plane, right? And then the last one, level 4. Okay. Now, what happened? Oh no! Level 4 is not showing anything. When we have level 4 selected, we can see its properties. It says this is a floor plan. It's an architectural floor plan. You can change the scale, let's say 8 scale, or if you need to change that to fit the drawing on a certain size sheet or something. But if you go down, and go down, and go down, you can see depth clipping, view range. I'm just going to say view range. And right now I'm just going to say the view level, I'm going to say unlimited. And let's hit apply and see what that does. There we go. Now we can see everything below. Again, everything you select on that screen or anything you select here will have properties that we can begin to modify. So when we start to build some columns next, you'll start to see their properties here and we can begin to change them. Okay. All right. Hey, speaking of, do you guys want to build some columns? Yeah, that's the next step, right? I'd say so. Okay, let me just look at this one more time. Let's make this unlimited. Let's hit OK. All right, now, see what I did? I set the bottom unlimited, view depth unlimited, hit apply, hit OK. Now I can see all the way down. Let's see here. What else? Oh, yes, columns. Right. So you'll see that in structures, there's also columns that you can put in here, like structural columns, steel columns, and they'll actually, ask you what kind of column you want and be very specific about, is it a hollow steel tube? Or is it a concrete rectangular column, or is it W shape? But let's just go to the architecture tab and let's use architecture columns. Right? Those are going to work well with walls and floors when we start. They're very generic. So I'm going to say not structural column, but architectural column. So in the architecture tab, column, architecture column. All right, you can see again, before I even place one single column, I have a number of settings here. So it's asking me what kind of column and what are its properties. Is it a rectangular column? Is it a metal clad round column? I'm just going to do an 18 by 18 square column. All right. I'm going to go to level 1 and I'm just going to start placing columns here at my center line. Now look, I have a couple of things also checked here. Move with grids, right? So as I start to place columns along the center lines of these grids, it's going to remember the relationship between the column and the grid lines. And if I start to move those grid lines, the column should move around with it. All right? So, click, 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 click. Nothing difficult about this. Now, before I go too much further, in fact, I'll just put in one really quickly. Okay. Let's go to the 3D view and see what it did. It put a column on level 1, right? Starting at level 1, and the top level is level 2. You can see the properties when I select it over here. Right? This becomes really important as we start to make architectural things in Revit. You want to look at their properties. So in this case, I wanted to go all the way up to level 4. I mean, come on, I'm going to make a column grid here. I'm going to change the top level to level 4. Hit apply. You can see that it now goes all the way up to level 4. Yeah, okay. Now, hopefully it'll remember that when I start to insert more, and so I don't have to keep changing all of their settings. We'll see. Architectural column, 18 by 18. All right, let's see. Click, 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 click. So far, I don't see any collisions with my diagrid. That's nice. There will be later. We'll have to deal with them, but. Click, click, click. All right. Now let's go to the 3D view. Oh, nope, okay. Apparently I have to set all of these now to their tops to be level 4, right? So what I'm doing is I'm selecting these objects. I can see their properties here, right? Now instead of having something over here in Grasshopper and something out here in Rhino that I'm looking at, it's all in one interface. But now I can start to say, what's the top level? I can give it a specific height, or I could say, whatever level 4 is, if I move it around, these things are going to update with it, right? So again, we're building in associations with these things. Is this making sense so far? I know it's probably dreadfully slow, but what I'd like for you to do over the weekend is to simply do this. Bring in your Rhino diagrid into here, establish the grid, then start to place objects along the grid. Columns, and then we'll do beams here in a minute as well. It seems a little repetitive, but what you will learn is the muscle memory of working inside Revit, which is different than AutoCAD and Rhino and Blender and all the Maya and all those other tools. For whatever reason, they just, maybe it's my magic mouse. It just doesn't, it's not compatible very well with moving around in Revit. I just, ugh. So I'm just gonna go ahead and click on all of these columns, and I'm gonna move them all so that their height, right, is at level 4. And I can do that just by simply changing the parameters around, right? Oh. Well, I think about great uses of columns over the millennia. Just think what the great Mosque of Cordoba could have done with this, with Revit, just making columns all over the place. All right, so let's see. You guys have history? Yeah? All right. So again, I'm just going through and doing these one by one because I'm too stupid to figure out how to do it, how to change it once and then keep placing things. Some of you guys probably know already, right? So a couple of things I'm going to look at here. One is, I'm going to notice that there's a couple of collisions that we have here, right? So I'll need to readjust some of these columns because, you know, it's physically impossible to have steel self-intersect steel, right? Like right over here where my cursor is. See that? That's a collision, right? So we want to avoid those sorts of things. So that's where I might need to readjust that column to stop and end before we get into that diagram. And there's a couple of other places where I need to do that too, probably. So let me just do that. Let's go to, let's see, let's just have it go up to level 2 and see what that does. Now let's try level 3, see what that does. Nope, that clearly goes through, okay. So we have to stop at level 2 on that column. And let's see, just tilt this up a bit. So far, so good. Let's see what it looks like from that side. I'll just click on that corner, and it'll rearrange my, okay, I can see I have a couple of conflicts here I have to deal with as well, right? Right there, that column. Let me click on it, and I'll end that at level 3. There we go. And it looks like this column as well is having some issues. Clearly that's not going to work. Structural engineers don't like it when you have steel trying to intersect steel. They really despise that. I can see their point. Yep, so I have to end that at level 2 as well. All right. Ta-da! Yeah, so you'll have to do the same thing with yours, right? You'll have to sort of build this grid and then try to figure out what parts do I have to sort of start to select and delete away or manipulate in order to sort of avoid those collisions. All right, we're almost there. I can tell you guys are excited by the blank stares on your faces. It'll be a short day today, though, at least, so that's good. All right. You guys ready to put in some beams? Yeah, all right. You guys taking structures? Have you guys talked about W shapes? Steel beams? All right, we'll talk about that just in here in a second. All right, so we don't need beams along the bottom, okay, but we will put them, let's say, underneath the second floor and underneath the third floor and underneath the roof on the fourth level, right? So let's go to level 2 architectural plan. There we are. You can see all of our columns. See that one ends before we get to level 2. That one ends right before we get to level 2. So you just see it lighter in elevation. All these others are being cut in section. So let's start to make some beams. Now there aren't any architectural beams, at least that I've seen. You could probably make some sort of component yourself. I find Revit completely unconvincing as like a freeform modeling software. I mean, it's just like a pain in the rear. But what we can do is we can go to the structure tab and we can look at the beams here, right? Now I just made the beam tool. By default, it says, okay, you can draw a straight line and we'll place a beam along that straight line. And then it says in the properties, it asks for what kind of beam do you want? We have C shapes. We have just like a centerline reference, or we have W shapes. W shapes, wide flanges, look like this. You might call them I beams because they look like a capital I. Those are W flanges, right? Wide flanges. So you have a webbing and you have the flanges on top and bottom. Right? So when you see these W6 by 15 or W12 by 26, the first number is the depth in inches, right? So W12, 12 inches deep or 1 foot. The second number, 26, is the weight in pounds per linear foot. So every foot of this beam weighs 26 pounds. And that talks about how beefy the flanges are, and it also might be the webbing. So the more dense it is, right? Imagine 50 feet for every linear foot. Like dead weight that, now put two of them together, 100 pounds, just 2 feet of beam, right? Steel's heavy, no? All right, so what we'll do is we'll go ahead and we'll stick with W12s by 26, right? Now I'm in the level 2 architecture plan. I'm just going to zoom in, and what I'm not going to draw them to the center line. I'm going to actually have them frame into the columns from the side. So I'm going to make sure I'm snapping to the edge here each time. Now you'll see in plan, I just get a center line for the beam. And if I look at it in 3 dimensions, let's see what I drew. Oh, there's our wide flange. Look at that, right? 12 inches deep. Now, there's a couple of things I've got to think about here, right? We can look up and sort of see what we're dealing with, right? What we typically call this region between the finished floor on the second floor all the way down to how we're running systems. Sometimes we even have a drop ceiling. We call that the floor to ceiling sandwich, meaning that there's layers of stuff in between the bottom and the top, right? I mean, personally, I kind of find sandwich metaphor kind of, I mean, I'm just always hungry, so it is what it is. But anyway, right, so you can see that we have concrete slab poured on a corrugated metal deck. That metal deck is spanning between beams, right? And then we have systems running underneath those beams, right? Air, plenums, ductwork. We have raceways with data and electrical, and then conduit running out. We have drop-downs for projectors, lights, power, etc. Right? So a lot going on in between in that sandwich. Right? Okay. So what I'm going to do is I'm going to think about that beam, and right now our beams are like as if we were stepping on the beam on the second floor. Right? They come right up to that finished floor level. When in fact we have a slab and then corrugated decking underneath that slab, right? And then we have beams underneath that, running up the slab of the deck. So what we need to do is we need to offset this down, anticipating how much floor we're going to have on top of it, right? All right. So I'm just really quickly, let's talk through this really quickly, right? Like I think in 3D view, we'll go back and forth between, sorry, I don't know why it's showing windows, but we'll go back and forth between the plan view and the 3D view so we can sort of see what we're talking about here. So if I go to level 2 And I'm going to actually go to the architecture tab and I'm going to build a floor. Right here, ta-da, architectural floor. And it'll tell me like draw the boundary, draw a shape, and it'll fill it in with floor when I hit the green check mark, right? So I'm going to go ahead and do that. Let's see. Maybe. Here we go. I'm just going to draw it in between these columns so we can sort of compare things, right? When I'm done, I'll go ahead and hit green. You can see I've built a floor. Let's go to the 3D view, right? Now you can see that the top of the beam and the top of the floor are the exact same level, when in fact the floor would be sitting on top of the beam, right? Right now they're like this, again, conflicting or colliding with each other, right? Whereas we can see here that the floor slab is going to sit on top of the beam, right? So we need to move that beam down. So we're going to look at that floor, and we're going to look and see and make a decision on the thickness of this floor. By default, to just put in a floor, generic 12-inch floor. That's kind of deep, honestly, especially for this span, only 15 feet. But for our purposes, we'll just use it, 12 inches deep. All right? Maybe that also includes some purlins going back and forth, or I don't know, something like that. So now what we need to do is we need to go back to our beam, just click on that, and let's take a look at more of its properties. We already told it what the cross-sectional shape is. It's going to be 12 inches deep, a W12, and then, standard W12 by 26, right? That's how it gets its geometry, and then it sort of just sweeps it along that rail. We can start to look at things like level offset, start level offset, end level offset, but Z offset value is what I'm going to look at. Right? So right now, Z justification, if I draw a line, it's going to put the top of the beam at that line. What I can do is I can actually offset from that line down, right? So I could say -1. Let's try it. Let's see what happens when we do that. The Z offset value, I'll say -1, and hit apply. And look at that. Now you can see that the slab is actually sitting on top, on top of the beam, right? Just like we wanted. Okay, so now that I have this value, I know I can offset this -1. I'm good to go to start making beams all day long. I can make beams like the day is long. There we go. All right, so let's go back to L2. There we are. And I'm going to go ahead back to structure, beam, make sure I have W12 by 26. And that Z offset value, I'm going to go ahead and set that to -1 right now. Now, every time I make a new beam, it's going to be offset 1 foot below the level 2, so it'll be right underneath the slab later on when I start to insert floors, 12-inch floors. Okay, so let's see. I've already done this one, so let me just bear with me here. But I'm going to try to make them flush here so they look like they're actually framing into the side and of these columns, as if maybe the columns are really beefy hollow steel tubes. Okay. Maybe I'll come over here and do it over here, right? Maybe I'll also, these are 18 by 18 inch columns, so when I find a point over here, it's usually 9 inches away from the center line. Just simple arithmetic. 13.5 feet long. Let's just look at the 3D model. Yeah, I'm starting to fill this thing in with beams, right? Hooray! I can do that at level 2, and then level 3, and then level 4. I'll start at level 3 here. I mean, there's an issue here with some of the level 3 and level 4, right? In that we have some beams spanning between 2 bays, right? Where we've actually cut a column short so we don't conflict with the digrid. So we have to also sort of look at these things three-dimensionally to better understand where we need these things and where we don't. Let's say I go to level 4 and draw a beam. It's asking me to save the project. I'm not going to do that right now. I have better things to do with my time. You guys should save early, save often though. Right? This one's actually going to go 2 bays all the way over to this one. Because at level 4 there is no column here. And it'll probably do the same thing over here. These things will look like they conflict. I don't really, when they crisscross, I don't necessarily care so much. Let's go to that. So you can see up there, right? And I'll have one here, have one here. These two actually span 2 bays because the column has to stop short. Okay? And that's what I'm doing. That's what I expect you guys just to work on over the weekend, right? The key thing is you open up Revit, you get your hands dirty, you mess up, right? That's how you learn. You make some mistakes and you figure out how to unmake the mistakes, right? Okay. And, whoa, I just got like vertigo, like seeing the projection shake. It's like way too much deflection in these floors for my taste, especially when we put projectors on them. Maybe they should have gone from, gone with the W16 by 48s instead of the 36s. I don't know. Anyway. No? Oh, come on. Throw me a bone here. All right. But that's what I'm asking you to do. All right? Go through methodically and try to establish a grid. That will make establishing walls and floors really easy. Okay? Now on Monday when we come back, we'll take a look at what you've done, right? This is a lot of just being in class and trying things along work. What was I going to say? Oh, right. We'll have some rules, right? We'll have sort of a game to play on how you can start to insert planes and what size they can be and how many of them you can use, right? So this becomes truly a planar composition rather than just a bunch of 4-walled rooms that look like garbage. Nothing worse than developing a floor plan and just extruding it up, making a layer cake. You don't need to go to architecture school for 6 years to do that, right? All right. So, we'll have some interesting things to do here, right? So again, go back to your Rhino file, clean some things up, save a version out that only has the diagram geometry in it, right? Those struts and the lattice, right? The struts and nodes. Then you can open up Revit, import that in, start to establish the grid, and start to build a structural and architectural grid, right? With columns and beams. Yeah.
Is there going to be an assignment period for us to submit this to?
Say again?
Is there going to be an assignment period for us to submit this to?
No. But if you don't have it done by Monday, you're going to start falling behind, right? So try it before the weekend, and if you have any problems, start emailing me or knocking on my office door, okay? Now, if Monday comes and everybody's having problems, we'll slow down. That's fine. But if you need extra help, just see me. I have office hours, and I'm always willing to meet outside of office hours as well. So that's not a big deal. Yeah. I'm not sure. I'm not sure, but I think you have to do it in plan view because it wants to know where you're actually placing them in Z. Does that make sense? So if you're in level 2 versus level 3 or level 4, that's good. Okay, so let's try it though. Why not? I mean, we can see. Let's see, structure, beam. But my guess is I could try to snap to something, but I'm not. It doesn't have any precision. So you're gonna have to go back and forth between those ortho views in order to do it. Right? So that's why I would say start with level 2 first. Just get level 2 working, then go to level 3, get it working, level 4. Take your time, right? It might seem a little droll to sort of place beams everywhere, but it'll help you sort of, again, I don't mind a little bit of rote exercise at the beginning, repetition, because it helps you build a little bit of muscle memory with how you use the keyboard and the mouse with these tools, right? And this one's different than Rhino for sure. I remember learning AutoCAD, Z. I mean, this one's completely different. And how you use that mouse to move around the screen. When you zoom, when you don't, or with your mouse, your scroll button. It's ridiculously different. So, trying to keep. If you have any questions about that, you can come see me, or do what I would do when you come see me. Just Google it and watch a 2-minute YouTube video on it. Right? But again, take this weekend to sort of just carve out an hour or two just to sort of play with the software. Do this step by step, try it out step by step, and try to develop some of that muscle memory.
How much is Revit versus CAD? I know Ray wants to go, but I'm just curious, how much is Revit? I mean, like, I was really well trained in
How
CAD.
much is
So
Revit?
how much is Revit used in architecture offices now? They don't use CAD anymore?
It's used pretty widely. I mean, 20 years ago, the GSA, General Service Administration, made BIM models an official deliverable, not just a drawing set. So since then, it's snowballed.
And it's
Most,
like-
most firms are using BIM, right? And the market in the US is mostly Autodesk Revit. So yeah, I mean, AutoCAD is all about just replicating what a pencil can do, right? This is much smarter, and it's made to improve communication between architects and the consultants, right? And then further the contractor and subcontractors, reduce errors and increase delivery, or sorry, decrease delivery time.
So
It
it's,
hits all the check marks that any developer wants.
it's kind of replacing CAD. It's not
Oh, yeah.
adjacent.
Definitely.
Okay.
Right. I can extract any CAD drawing just by simply clicking floor plan, section, elevation, right? This is a four-dimensional database, really. And the drawing sets are linked up parametrically. So you generate drawing sets. Rather than drawing something that's three-dimensional, you're building the virtual three-dimensional thing, extracting the two-dimensional drawings. Does that make sense? That shift? Yeah. Okay, yeah, no problem. It's, any other questions? Again, the recording today, I'll go ahead and add a new page and a new module for project 2, after class, right after class, teaching class in studio. And I'll go ahead and take care of that, get that up for you. I don't have it like submit a screenshot or something for Monday, right? Your accountability is your own, right? If you have problems, again, all I ask is that you communicate with me, right? I can meet with you however long I need to get you up to speed or make sure you're understanding stuff on an individual basis, if need be, right? So again, just keep that in mind, right? All I ask is that you communicate with me and don't let this stuff stack up, right? It's a lot easier to say, oh, you're like a meeting or a week behind, rather than like, it gets to November and you're like, how do I start project 2? I'm like, good grief, right? We'll draw a model, we'll draw a Revit model of how to get to the registrar and drop the course. That's what I would say for you if you're asking about project 2. Because we'll already be in project 2, finishing project 3. My goal, project 3 is involved, because you'll be also using laser cutting and digital fabrication. We'll be doing some performance-based stuff. But my goal is that we finish things up before Thanksgiving holidays. Knowing that when you come back from Thanksgiving, you guys are gonna be super busy trying to finish up studio and then prepare for all the final things, the week afterwards. So I like to try to avoid having lots of big assignments in this class, laser cutting in this class, when the whole school wants to laser cut their final models, right, for their studio. I'm mindful of that, and I just try to make this a pleasant experience for everybody by simply trying to keep things wrapped up sooner rather than later. That said, I usually also give a grace period where even into finals week, you have time to submit if you need extra time. But I'd like to keep up a pace where we actually wrap things up and avoid sort of glut at the end with the laser cutting and with your time, right, and your sleep. I know it gets very tiring and stressful at the end, so that's why I try to make it light at the end of this class. Plus, I mean, who am I kidding? The last week of classes, you guys won't come to this class. You guys have been pulling all-nighters, either at the printers trying to get things plotted, or taking a nap for a few hours before your final presentation or something. I mean, I know how it works. I teach studio too. Any questions? All right, so this is going to be a quick project 2. What we're going to do is we're build some stuff, and then we're gonna start to do some rendering and do some Photoshop collages. And then we'll move right on to the Performance Grid show. I bought some examples sitting in my office already, and you can take a look at them. All right, go fight Lynn. See you next week.